Hi, this is King of Review. Here we have an inequality with 2 log of x's, and we have to find the value of alpha times beta, where alpha is less than x, which is less than beta. So, to figure out alpha times beta, we have to figure out what alpha and beta are. So hopefully we can solve this inequality on the left so that it looks like some number is less than x is less than some other number. So, in this inequality on the left, we have the log of x squared, then we have the log of x to the 5th. Now, it would be nice if we could do something with this 5 so that we had an inequality that just was in terms of log of x. And we can. There's a nice property of logs that if you have the log base b of x to the power a, you can take that a exponent and bring it in front of the log so that it becomes a times the log base b of x. So let's apply that property in our inequality. We have the log of x squared minus 5 times the log of x is less than 6. And now, since we have the log of x squared in one term and the log of x by itself in another term, it might be easier to define a new variable y as the log of x. Because now we can replace the log of x with y, and we see that we have a very simple quadratic inequality to solve. Easiest way to solve quadratics is to set them equal to 0. So if I move the 6 to the left side, I now have this, and I'm hoping that the left side of this equation factors. I can put a y in both parentheses since y times y is y squared. And now I need two numbers that multiply to negative 6 and add up to negative 5. And that would be negative 6 and positive 1. So it does factor. Now, if this equation is going to be, if this expression on the left is going to be less than 0, there's two possibilities. If these two numbers multiply to be a negative number, either the first one is positive and the second one is negative, or vice versa. The first one is negative and the second one is positive. So let's see. The first possibility, y is greater than 6 and y is less than negative 1. Well, it's impossible to have a number bigger than 6 and also less than negative 1 at the same time. So this is out. Let's try this solution on the right. Y is less than 6 and y is greater than negative 1. Well, you can definitely have a number smaller than 6 and greater than negative 1. If we think about this on a number line, that's all the numbers in between negative 1 and 6. So our solution is negative 1 is less than y, which is less than 6. Let's change y back into the log of x. And now we have alpha and beta. Alpha is negative 1, beta is 6. But we have a problem. We still have a log here. To get rid of a log, we can use a property that logs and exponents are opposites. So if you take a base b, raise it to the power of the log base b of x, the log and the b cancels and you just get x. Since this log has a base of 10, let's raise 10 to the power of all three pieces of this inequality. 10 to the negative first is 1 over 10, 10 to the log base 10 cancels out and we just get x, and 10 to the 6th is a 1 with 6 zeros after it, so 1 million. So now that we have x by itself, we really know what alpha and beta are. Alpha is 1/10, beta is 100,000, so if we want alpha times beta, that would be, not 100,000, 1 million divided by 10, which is 100,000. So there is our answer for alpha times beta. And that's it. Thanks for watching.